Assalamualaikum, hi everyone. So this is a video for chapter 7, Haloalkanes. In this video, we're going to discuss the subtopic 7.1, Introduction to Haloalkanes, and at the end of this lesson, you should be able to first draw structures and classify primary, secondary, and tertiary alkyl halides. This is your haloalkane. Name the primary, secondary, and tertiary haloalkanes according to the IUPAC nomenclature. And lastly, describe haloalkanes as compound that contain polar bond and the carbon bearing the halogen is susceptible to nucleophilic attack. So now let's start. So we're going to talk first about haloalkanes, or sometimes it is also called as alkyl halides. Okay, so haloalkane is a compound contain halogen atom, usually we put as X as the general atom, which bonded to an sp3 hybridized carbon atom. Okay, so this is our halogen and this is our carbon. So from this carbon hydrogen bond, so our halogens is a very electronegative atom. Okay, so since there is difference in electronegativity over here, so the halogen, either chlorine, iodine, or bromine, is partially positive, and also fluorine, also will become partially negative, and the carbon over here will become partially positive. So this is the general formula for our haloalkanes, Rx. So X here stands for fluorine, chlorine, bromine, or iodine, and R over here is our alkyl group. Okay, so it is also called as alkyl halides. Now let's look on how to class our haloalkane. Classification of haloalkane, it will depends on the classification of carbon that bonds to the halogen. So like we did before, we focus on that one particular carbon and look how many carbon does that carbon bonds to. So if it's bond to one carbon, it's a primary carbon. Bond to secondary, bonded to 3 carbons, so tertiary carbon. It's just that for haloalkanes, we need to identify first where is the carbon bonded to halogens, because we're going to determine that particular carbon. We're going to class that particular carbon. So let's look at this table. So we have 4 classification: methyl halide, primary, secondary, and lastly tertiary halides. Okay, so how are we going to class? So if you look at this one, so find your halogen. So this is my halogen, this is our halogen. This halogen bonded to this carbon. Okay, so this carbon is only bonded to hydrogens. It does not bond to any other carbon. So that's why it is classed as a methyl halide. So halide here refers to your halogens. Okay, so let's look at the next one, this one. Okay, so for this one, this is our halogen. This halogen is bonded to this carbon. Okay, so if you look at this carbon, it is bonded to one carbon, one methyl group CH3 over there. So this particular carbon which bonded to Cl over here is a primary carbon. So that's why we class it as primary haloalkane. Okay, the next structure, this one. Okay, so for this one, this is our halogen. This is the carbon that is bonded to the halogen. Okay, so this carbon is bonded to 2 carbon. So this particular carbon is a secondary carbon. So the overall structure will become a secondary haloalkanes. Okay, and then lastly, this carbon. This is bromine, your bromine. Okay, bonded to this carbon. So this particular carbon is bonded to 1, 2, 3 carbon. So the carbon that bonds to the halogen, to the bromine, is a tertiary carbon. So overall, it's a tertiary haloalkanes. So now, we're going to look on the nomenclature of haloalkanes. How do we name haloalkanes? Based on the IUPAC nomenclature. The IUPAC nomenclature for haloalkanes follows the basic rule as described in alkanes. So we're just going to follow everything that we have learned in naming alkanes. It's just that with the halogens, we're going to put, for example, fluorine as fluoro, chlorine as chloro, bromine, bromo, iodine, iodo. So that's the only difference, because we treat the haloalkanes, the halogens over here, as a functional group. So we need to give a name for that particular substance. So the parent name will always be the parent name of the alkane. So our halogens over here, it becomes a substituent. Now let's take a look at a few scenarios on how we name our haloalkane. The first one, number parent chain beginning at the end nearer to the first substituent, regardless of whether it is alkyl or halogens. So we treat both halogen and alkyl as a substituent. The longest carbon chain will be our alkane. Okay, the parent name will be the name of an alkane. Okay, so for example over here, okay, so I have this one structure. So locate the longest carbon chain. Okay, so our longest carbon chain, we have over here a 7 carbon alkane. Okay, so this is the longest carbon chain. So we have over here 3 substituents. So the number, okay, we number it from the left hand side over here, so that we get a combination of 2, 4 and 5. If you number it from the right, so 1, 2, 3, 4, 5, 6. So you will have 3, 4 and then 6. So it's a bigger combination number. So that's why we take it from the left. Okay, so the parent name 7 carbon is heptane. Our substituent over here, we have 2 methyl group. Okay, so it will be 2,4-dimethyl, and at the 5th carbon we have bromine. So as a substituent, the name will be bromo. So 5-bromo. So combine the parent name and the substituent. So you get this structure as 5-bromo 2,4-dimethyl heptane. Next, treat your halogens exactly like alkyl for numbering and alphabetizing purpose. So what does this mean? Okay, so for example, I have this structure, and as you can see over here, this is the longest carbon chain, and we have 2 substituents over here. Okay, so if you look over here, I already number it from the left. Okay, why? Okay, if I number it from the right, so 1, 2, 3, 4, 5, 6. So the position of the methyl, okay, so let me just scribble it down with blue color pen. Okay, so 1, 2, 3, 4, 5 and 6. Okay, so if it's the blue color combination, so we get 2 methyl, okay, and then we get 5 bromo. And if we use the red color combination, okay, so it will be 5 methyl and 2 bromo. Okay, so why do we choose the red color one? Because since the position, the combination number is the same, 2 and 5, regardless it is from the left or from the right, so we choose the one, we prioritize the alphabetical order. So since B came first, after that is M, so that's why we give the lowest number to bromine. Okay, so we have a 6 carbon alkane over here, so the parent name will be hexane, and the substituent will be 5 methyl and 2 bromo. So we're going to use the red colored one over here. So the name of the compound, the name of the haloalkane will be 2-bromo 5-methyl hexane. Next, when we have 3 or more substituents present, so what shall we do? Okay, you will begin at the substituent that leads to the lowest set of location number. Okay, so regardless the alphabetical order, if you have more than 3 substituents, okay, we're going to choose the lowest combination number. So for example, we have this structure. So if you look over here, this is the longest carbon chain. So we have 1, 2, 3, 4, 5, and 6. 6 carbon alkane over here, 6 carbon backbone. Okay, and then here is our 4 substituent. Okay, so you have two options, either to number it from the left or to number it from the right. Okay, so we need to give the lowest combination number to our substituent. So if I number it from the left, from the right, this is my right. Okay, this is our right. From the right, it will be 1, 2, 3. Okay, so let me just write it down. Okay, so this is at carbon 3. Okay, and then 4, 5. This is at carbon 5. So if it's from the right to left. Okay, but if we count from left to right, so this is carbon 1. Okay, carbon 1, so this will be carbon 2, 3, and 4. So the lowest combination will be from the left to the right. So that's why we're going to number it like this. Okay, so instead of 5 dimethyl, 3 bromo, and 3 chloro, okay, so we will not choose this numbering. So the parent name, we will have 6 carbon alkane is an hexane. Okay, so the substituent is 2,2-dimethyl, 4 bromo, and 4 chloro. So these are the substituents. So to write down the name, we're going to follow the alphabetical order. So the alphabetical order, it will go from B to C and then M. Di over here is not part of the alphabetical order. The alphabets we need to consider is C, B, and M. So the name will be 4-bromo, 4-chloro, 2,2-dimethyl hexane. Okay, so far we have discussed a linear chain alkane. Okay, now we're going to look on a cyclic haloalkane. Okay, haloalkane with a cyclic structure. So if you only have one substituent present on your cyclic structure, so for example, this one. Okay, so no number is needed. We can straight away name this compound, okay, by identifying the parent chain. So this is the parent chain, the 6 carbon cyclic structure. So we have cyclohexane, and at the cyclohexane we have an iodine. Okay, so you don't have to number this iodine because you only have one, so numbering is not necessary. Okay, so the parent name will be cyclohexane. The substituent, the iodine, will become iodo. So the name will be iodocyclohexane. So O and C over here, it must be in one word. Okay, you don't have to put any comma. You don't have to put any dash or an hyphen over there. Okay, so it needs to be written as one word, iodocyclohexane. So when two different substituents are present, number the ring by alphabetical priority. Okay, so what does it mean? So for example, here we have a cyclic structure. Okay, so this will be the parent chain. So you will have cyclohexane over here. Okay, so let me just write it down. So here you have cyclohexane. So on this cyclohexane, you have two substituents. Okay, you have chlorine and you have iodine. Okay, so here is chloro, here is iodo. So which substituent will be carbon number 1? Okay, so since carbon C came first and then I, so that particular carbon over here will be given as number 1. Okay, so when numbering this one, okay, so either you go clockwise or anti-clockwise. Okay, so choose the lowest possible number. So for this one, if we go clockwise or anti-clockwise, we will still get the same combination. Okay, so number 1 from Cl. Okay, so as you can see over here, we number it clockwise. So 1-chloro-4-iodo-cyclohexane. So the parent cyclohexane, substituent 1-chloro and 4-iodo. So the full name will be 1-chloro-4-iodo-cyclohexane. So when 3 or more substituents are present, we're going to begin the numbering at the substituent that leads to the lowest set of location numbers. So easy, find the lowest combination number. So for example, I have this structure. Okay, so one carbon has 2 substituents, the other one has 1. So confirm we're going to start from this one. Okay, because it will give us the lowest combination. So if I give this carbon number 1, so I will have 1, 1 and then 4. But if I give chlorine over here number 1, so 1, 2, 3, 4, so I will get 1, 4, 4. So the combination of 1, 4 and 4 is bigger compared to 1, 1 and 4. Okay, so you have your parent over here. So the parent name will be cyclohexane. The substituents that we have is chloro, iodo and methyl. So numbering will start from this carbon. So we will have the parent as a cyclohexane. At the first carbon we have 1 iodo, 1 methyl, and at the fourth carbon we have 4 chloro. So combine all together, write down the name, use alphabetical order. So it will be 4 chloro, 1 iodo, 1 methyl cyclohexane. Next, we're going to look on the polarity of haloalkanes. So this polarity is very important. Okay, why is it important? Because at the polar side of the haloalkanes, reaction will occur. Okay, so now let's take a look. So we have a polar CX bond. Okay, so what does it mean? So the electronegative halogen X will create a polar CX bond, making carbon atom electron deficient. Okay, so as we know, halogens is one of the most electronegative group in your periodic table. So when it's bonded to carbon, okay, it will create a polarity, okay, where carbon will be partially positive and your halogen will be partially negative. Okay, so the chemistry of haloalkane is determined by this polar CX bond. Okay, in other words, the reaction will occur at this polar CX bond. Okay, so this is what I meant just now. So at the carbon, we have partially positive side, X partially negative. So this is your electrophilic side. This is your nucleophilic side. So reaction will start from here. Okay, so the carbon is electrophilic and the halogen is nucleophilic. So this carbon is susceptible to nucleophilic attack. So in other words, this carbon is very easy to be attacked by a nucleophile. Meaning, if I have a nucleophile over here, since this is an electrophilic site, nucleophile will go and attack your carbon. Okay, so once nucleophile attach to the partially positive carbon, okay, the carbon halogen bond will break, where the 2 electrons will go to your halogens. Okay, so that will be all for this video for the introduction for your haloalkane. Okay, and how to name and then where the reaction will occur. So I will see you on the next video for haloalkane. Thank you.